talk about atom, we normally visualize atom to be a spherical object with nucleus as a core part, and we normally imagine some particle revolve around the nucleus. Now whenever we want to find out the radius of the path along which the particle flows around the nucleus, then we normally determine the radius using some parameters, something like centripetal force and electrostatic force. Now we know what is the centripetal force. Centripetal force normally is the force that acts between the two particles, and in such a way so that one particle revolves and the direction of the resultant direction points towards the center around which it revolves. Accordingly, centripetal force we normally know by the relation mass into velocity square divided by the radius of the path along which the particle flows, where velocity, v is the velocity of the particle when it moves and m is the mass of that particle. Now the question is, who is providing their centripetal force? The centripetal force is provided by the charged particles of the atom. Normally the particles that resides within the nucleus is considered to be the positive charge, and the particles which revolve around the nucleus is considered to be the negative charge. Now we know from the Coulomb's law that the relation between the force between the two charged particle is given by the product of the charge of the two particles, which we consider E in this case. So E into E gives E square, then some constant divided by the square of the distance between the two, where the distance is regarded as the radius between the two particles. One is the nucleus and the other the one which moves around the fixed particle. Now when we equate this, why we are equating this? Because electrostatic force is the one which is responsible for the centripetal force. Now when we equate this, we can simplify the expression into more reliable form. We can write like this. Now we can see in this expression there are two unknown quantities. One is the velocity and one is the radius. Our next job will be to find out these unknown parameters, because when we find out these unknown parameters, we can easily determine the features of the atoms. Now one of the parameter is radius. Now how to find out the radius? There was a postulate given by Bohr, and the postulate, and according to this postulate, it's mvr equals to nh by 2 pi, where mvr is denoted as the angular momentum of the rotating particle, h is the Planck's constant, this whole parameter is the constant, and n is the number of that constant. This is done by the Bohr's postulate, which we already discussed. Now if we equate this one with this one, or rather than if we replace velocity from here in here, then what we can do, we can eradicate or eliminate velocity. So in this case we can simplify, or we can simply write n h by 2 pi m into r, where m and m gets cancelled in this case, and we have k e square by r. But then one more important thing is that this is a square part, so 1 m still remained and 1 m gets cancelled over here. Let me write like this to be precise. Now using this expression we can see there is one unknown quantity is eliminated, it's eradicated, because of which we are left out with only one parameter, and if you further simplify you are going to get the equation given by this one, r equals to n square h square by mke square. Now also we know one more important part, that in atom there are more than one path along which the electron flows. So we can picturize atom to be of this sort. Now if we calculate the radius of the first orbit, then what we term this one as Bohr's radius. Why it's Bohr's radius? Because Bohr calculated this one. So we can calculate the Bohr's radius, and it came out to be this one. Now Bohr's radius is simple. We are considering the first orbit, and the value for the first orbit is parameterized to be n equals to 1. Now if you can put this value of n equals to 1 here, we can easily find out the radius of the Bohr's orbit, which is denoted by r0, and the radius of the Bohr's orbit is written here. And in case of simple system, that is hydrogen, in case of hydrogen the atomic number is 1. So in case of the simplified system, the radius is found out to be 0.5. angstrom unit. Now this is how we can find out the radius. Now if we go back to the equation, where we have mv square equals to ke square by r. Here again we are coming back to the two unknown parameters. Now again using Bohr's postulate, where we have mvr equals to nh by 2 pi. Again using Bohr's postulate, if I make r as a subject and if I replace this value over here, then we can eradicate with r, and we are left out with mv square equals to ke square divided by n h into 2 pi mv. So now here we can see that there is only one unknown parameter, that is velocity, and if we further simplify, we can get the velocity to be this one, and this velocity is nothing but the velocity with which the electron moves around the nucleus. So this is how we can calculate the velocity and the radius of the Bohr. Okay, in this with respect to this topic, there was a question which was already asked in the year 1992. Now the question is simple: if you know the first radius, what will be the radius of the second orbit? If you know the radius of the first orbit, what will be the radius of the second orbit? Now in order to calculate that, we have to go back to the formula which reads that if you look back the formula, it's something like the radius of the second orbit given by the n square times the radius of the first orbit, if you compare the two. Now how we can consider whether the radius is of the first orbit or not? We normally see the value of n. Now if we see the value of n, if the value of n is 1, then we consider this to be the radius of the first orbit. If the value of the n is 2, we consider this to be the radius of the second orbit. Now in this regard, if radius of the first orbit is found out to be 0.53 angstrom, so the radius of the second orbit, as asked in the question, will of course be n square times the 0.53 angstrom. But here they gave r naught. They simply represented this one as r naught. Now what about this n2? For the second orbit, n will be equals to 2. Here they have asked about the second orbit. So for the second orbit, the value of the n is 2. Now if we put this value of n over here, then we easily get r2 as 4 times the r naught, which normally displayed in the option number A. Now similarly, we can consider about similar sort of questions can be asked. Now they have asked about the second orbit, they can ask about the third orbit. Now for the third orbit, the value of n will be 3. For the fourth orbit, the value of n will be 4, and so on. And if they ask about, here they have asked about the hydrogen atom. So for the hydrogen atom, the value of Z is considered to be the 1. Now if they ask about any other atom, accordingly you have to put the value of Z, and then you have to simplify the formula. You get back the Bohr's radius of the first orbit, and then accordingly you calculate the radius of the any other orbit.